Welcome again, Wildcats. All right, so today we're looking at Monday, October 24th, matrix operations, and that's going to be on page 24. So if you would, pause the video and update your table of contents. All right, now that your table of contents are updated, let's look at the notes. All right, so we're looking at matrix operations. Now you might pause the video a minute and get two colors to help with the notes, but we're going to have matrix A and matrix B, which I put A in blue and B in green. All right. Now, when adding or subtracting matrices, they must have the same dimensions. So what that means is that A has 2 rows and 2 columns. Okay, B has 2 rows and 2 columns. So since they both have 2 rows and 2 columns, they're the same dimensions, so you can add or subtract them. So to add them, and I've color coded this, and it's very important to do this so you can see what we're doing. So basically what we do is we add the same position. So since A and E are in the same position, we add them. So A plus E. Since C and G are in the same position, we add C and G. Since B and F are in the same position, we add them. And since D and H are in the same position, we add them. Okay? And so the same thing is if you're subtracting. They're in the same position. Okay? All right. Now you can multiply two matrices if and only if the number of columns in the first matrix equals the number of rows in the second matrix. So since A has 2 rows and 2 columns, and B has 2 rows and 2 columns, we look at the middle. So since the columns equal the rows, we can multiply the matrices. If these numbers aren't the same in the middle, then it's not possible because the number of columns doesn't match the number of rows. Okay, but they match, so we can multiply. What's also cool about when you write this is the outside numbers tell you the dimensions of the matrix after multiplied. So we know that we're going to end up with a 2 by 2 when we're done. All right, so when you multiply, the best way to do it is to think of it like this. You're multiplying, and let me go get my green. I'll be right back. So it goes like this. If you multiply A times B, you multiply the row times the column, like that, okay? And so you do that, since it's 2 by 2, you do it twice. So row by column. All right, so we multiply A times A and B times E and G. Then we do it again. We multiply C, D times E and G. And then we have to do it again. So AB times F and H and CD times F and H. And again, if you're doing these notes without color markers or pencils, you're wasting time, because if you don't color code it, it's very, very hard to see the connection. Okay? So if you would, finish up your notes. All right, and let's look at examples. All right, so let's look at example number 1. And remember, this is going to be on page 24. Now, I'm going to color code the matrices, and I really recommend doing that. Okay, so I'm going to make A in blue. And I'm going to make B in green. All right, so to get credit on your assignment, I'm going to show you the steps needed for work. So here, we're going to add A and B. So -1 and 0 in the same position, so -1 plus 0. And let me take a step back before. You should actually double check to make sure. Now, when you're adding and subtracting, the dimensions have to match. So let's make sure A is a 2 by 2 and B is a 2 by 2. So since the dimensions match, we can add A and B. All right. So 4 and 5 are in the same position, so we add them. 4 plus 5. All right. Now we have 3 and negative 6 in the same position. So that's 3, and really it's 3 minus 6. And then 0 and 3 are in the same position, so we add them. So 0 plus 3. All right. So we now add them. And this is the work I want to see. I want you to set it up and then show the solution. So negative 1 plus 0 is negative 1. 4 plus 5 is 9. 3 minus 6 is negative 3. And 0 plus 3 is 3. So that's the work needed. This and this for credit when you do the assignment. Now I'm going to leave example 2, and I'll go over that in class. So let's look at example 3. All right, here you really don't need to color code A. What you really just need to do is say that we're going to do this. We're going to multiply negative 1/2 times A, which is 1, negative 3, negative 2, 4. All right, now when you multiply the outside number by every number inside the matrices. So negative 1/2 times 1 is negative 1/2. Negative 1/2 times negative 3 is a positive 3/2. Negative 1/2 times negative 2 is a positive 1. And negative 1/2 times 4 is a negative 2. All right, so let's look at example 4. Now, when multiplying, you need to make sure the dimensions match up. So A is a 1 by 2. And actually, let me write it up above here. A is a 1 by 2. And B is a 2 by 2. And remember, this is the row, column. So the columns match the number of rows. So the outside numbers tell you what the dimension of the matrix is going to be. So when you multiply A times B, it's going to be a 1 by 2 matrix. So what I would do is go ahead and it's going to have one row and 2 columns. Go ahead and actually set up that so you know that's where things are going. All right, now again, color coding is where it's going to be important. So I'm going to make A blue and B green. Don't know why I'm using green today, but something just came over me. Maybe it's just like a green day, but green seems like a good color for today. All right, let me grab a ruler and I'll be right back. All right. Let's straighten these lines up a little bit. All right. So when multiplying, remember we do row times column, row times column. Okay, row times column. So we multiply this row times this column. So that's 0 times 2. Now it's plus, but really it's a minus 1. So minus 1 times negative 3. Okay, so now again we do row times column. So row times column. So 0 times negative 5. Again, it's plus, but really it's a minus 1. So minus 1 times 4. All right. So 0 times 2 is 0. Negative 1 times negative 3 is a positive 3. 0 times negative 5 is 0. Negative 1 times 4 is a negative 4. All right, let's look at example 5. All right, so example 5. B is a 2 by 2. And A is a 1 by 2. And remember, this is the row, column, row, column. All right, so what you'll see here is that the columns and the rows don't match. And so you would put B times A is not possible. Because the column I'll tell you what, not possible looks pretty direct, not possible for an answer. So let's leave it at not possible. But the reason is because the column and the row didn't match. All right. I'm going to leave example 6 to do in class. Let's look at example 7. All right, so first things first, let's make sure, and when I'm doing this, it confuses me by having the A here when it's right here, so I'm actually going to ignore A here for when I do example 7 and actually put A equals over here. I find that I can actually understand the problem better when I actually see the order, so BA, so I'm seeing in this order. So B is a 2 by 3, and A is a 3 by 1. So the column and row match, and so we can multiply, and we know that it's going to be a 2 by 1 matrix. So we're going to have 2 rows and 1 column. All right. And again, color coding is going to be helpful, so let's stay consistent. B's been green all day. Let's keep it green. So we multiply the row by the column. So that's 4 times negative 2 and that's going to be, it's really plus, but since it's minus 3 times 5. It looks like we might need some more space here, so we'll extend our line out. All right, and then plus 1 times 1. All right, so then again, row times column. So row times column, so 2 times negative 2 plus 0 times 5, and that's minus 2 times 1. All right, so we have 4 times negative 2 is a negative 8, minus 15 plus 1. So negative 8 minus 15 is a negative 23, plus 1 is a negative 22. And then 2 times negative 2 is a negative 4, plus 0 minus 2, so that's a negative 6. All right. And then I'm going to leave example 8 and example 9 for class. All right, so that concludes the matrix operation notes and examples part of the video. And so I will see you in class tomorrow, and we'll go over example 2, 6, 8, and 9. And if you have questions, remember, you can always ask me to go back over example 1, 3, or 4, or 7. All right. As always, I want you to have a terrific Wildcat day.